Hello all. So today we will go through the basic shapes that are being encountered in the surface area and volumes. We will understand all the basics, and related to that we will study the different formulas related to them, and then we will easily understand them. So first let us go through cube. So the cube is made up of square faces. Cube is having square faces. And since it is made up of square faces, all sides of cubes are equal. All the edges of cubes are equal. Okay. So let us understand the lateral surface area or the curved surface area of cube. So the lateral surface area and curved surface area means you have to exclude the top and bottom face. We know that, for example, if we take the dice which we used to play Ludo, so in that what happens, you have 6 faces on which 1 is written, in another face 2 is written. Like this you have 6 faces. So when you exclude the top and bottom face, the side face will be the curved surface area or the lateral surface area. So out of the 6 faces we have 4 faces. So its area will be 4 into side square, which is equal to 4a square. Then the total surface area. Total surface area will be the area of the 6 faces. So 6 into side square. 6 into side square, which is equal to 6a square. Then the volume. So volume will be length into breadth into height. So it is having all three are same. So side cube, because length, breadth and height of the cube are same. So it will be a cube. Then let us go through the cuboid. So cube was made up of square faces. The cuboid will be made up of rectangular faces. Cuboid will be made up of rectangular faces. So let's go through it. Cuboid. So cuboid will be made up of rectangular faces. Means the length, breadth and height will be different. So this is a cuboid. So it will be having a length, a breadth and a height. So it is also having lateral surface area or the curved surface area. So if you imagine the geometry box, so the top face and the bottom face of the geometry box is same. This side face and this side face will be the same, and this side face and this side face will be the same. So look here, this face is made by the length and the breadth. You have to go to a corner. So this is the length, this is the breadth and this is the height. So this face will be made by L and B. Its opposite will also be L and B. This face will be L into H, LH. Similarly, its opposite will also be LH. And then here it will be B into H. This small face will be B into H. Its opposite will also be BH. So we have 2LB 2 times LB, 2 times LH and 2 times BH. So out of it is also having 6 faces. So 2 LB are there, 2 BH are there and 2 LH are there. So the lateral surface area will be, if you include the top and the bottom, the rest side part will be the lateral surface area or the curved surface area. So if we exclude the base, means this LB and this LB is excluded, means this area and this area is excluded. So what is remaining? It is remaining, this is excluded, so 2 BH and 2 LH is remaining. So 2 LH plus 2 BH. So when you take it out, 2H is common, so 2 whole L plus B into H. So this is the formula for the lateral surface area or curved surface area of cuboid. Then we will go through the total surface area. So total surface area will be 2 LB, 2 BH, 2 LH. So 2 times LB plus BH plus LH. Volume will be L into B into H. Then we will go through right circular cylinder. We will go through right circular cylinder. So in a right circular cylinder, we know that it has 2 circular faces. It has 2 circular faces. So right circular cylinder. So when we draw the right circular cylinder, it is having 2 circular faces. So the circular face will be having a radius and it is having a height. So the cylinder is a very practical example. When you hold a paper for more time, then what you do? You just roll it. The roll which you made is nothing but a right circular cylinder. The pen's refill, the pen refill, inside refill is nothing but a right circular cylinder. So this is also a right circular cylinder. So it is having one circular face and this circular face and a curved surface. So we'll go through the curved surface area of right circular cylinder. So curved surface area is the round part. This part is the curved surface area. So this area, how we calculate? So we calculate by the circumference of base into height. So the circumference here is a circle. So the circumference of circle of radius r is represented by 2 pi r. So the CSA will be circumference of base into height. So circumference of base is 2 pi r and into height. So it is the CSA of right circular cylinder. When you are going to calculate the total surface area of right circular cylinder, so you have to include the CSA plus these 2 circular faces. Area of 2 circular faces. The bottom circular face, the top circular face and the bottom circular face. So CSA is 2 pi RH plus area of 2 circular faces. So 2 circles are there, 2 pi r square. When you take it out, 2 pi r is common, so we get 2 pi r into r plus h. So it is the TSA of right circular cylinder. Now volume. To calculate the volume, you need the area. You need the area, how much area is there and how much height it is standing. So area of base into height. So area of base into height. So area of base, area of circle will be pi r square. So area of base means pi r square into h. So this is the volume of the cone. Now we'll go through the sphere. We'll go through sphere. So sphere is a geometrical figure which is having no edges. It is having no edges. So its CSA is given by 4 pi r square and its TSA is same. CSA and TSA is same. So it will be also 4 pi r square and its volume will be given by 4 by 3 pi r cube. Then we will go through the hemisphere. After hemisphere, we will go through the hollow right circular cylinder, hemisphere. So in hemisphere, we have one flat surface and one curved surface, and we have one flat surface. So to understand the hemisphere, what you can do, you have a watermelon. So that watermelon green portion is nothing but the CSA, and the red portion, when you cut it into half, the red portion is nothing but this flat surface. It's a circle, pi r square. Similarly, lemon, when you cut lemon into two halves, the yellow portion is the curved surface area, and the from where the juice comes, it is nothing but the flat surface circle. So it is the pi r square. So CSA of hemisphere will be 2 pi r square, which is nothing but half of a sphere, and TSA will be CSA, this yellow part plus this. So CSA plus flat area means area of the circle, So 2 pi r square plus pi r square, which is nothing but 3 pi r square, and the volume of hemisphere will be 2 by 3 pi r cube. Means the volume of sphere was 4 by 3 pi r cube. So half of sphere will be the volume of the hemisphere. Now we have left one geometrical figure, which is the cone. So first, before studying the hollow cylinder, we will go through the right circular cone. Right circular cone. So right circular cone is nothing but a birthday cap or the joker's cap. So the bottom portion is the circle, and we have a curved surface. So this curved line, this slanting line is known as slant height S or L. So this is the L, and its height is referred as H, and they make 90 degree with the radius. So here the slant height can be calculated by the Pythagoras theorem. L is the hypotenuse, so L will be equal to under root r square plus h square. Then we need to calculate the curved surface area. So curved surface area will be pi r into slant height. Then the total surface area will be this CSA plus area of circle. So area of circle, which is nothing but pi r L plus pi r square, which is equal to pi r into L plus r, and volume volume of cone, right circular cone is 1 by 3 times the volume of right circular cylinder. So 1 by 3 into pi r square h. Now we will go through the hollow cylinder. Right circular hollow cylinder. So this hollow cylinder, we will go through right circular hollow cylinder. So we get most of the questions from here only. So hollow means the gap is throughout. When the refill finished, so it is nothing but it will give a hollow cylinder, or the bamboo is a hollow cylinder. So for hollow cylinder, what we have? We will have a small circle and a big circle. We will have a small circle and a big circle. So this is nothing but the height. So this is small r, this is capital R. Okay. Inner radius and a outer radius. Height is same. It has a common height. So the CSA will be, so when it is hollow, it's like a bamboo. So outer CSA plus inner CSA. CSA will be outer CSA plus inner CSA. So outer CSA is 2 pi capital RH, inner CSA is 2 pi small RH. So when 2 pi H is taken as common, so R plus R. TSA will be, CSA means 2 pi capital RH plus 2 pi small RH CSA plus area of the two bases. So it's like this. So area of two bases will be, nothing is present here, only we need to calculate this. So it will be pi capital R square minus small r square. So there are two bottom and top, so 2 pi capital R square minus small r square. Then volume of a right circular hollow cylinder. So volume will be pi capital R square minus small r square whole into h, means area of base into height. So area of base is this into height. So I think you understand the basic formulas that are being used in calculation of the problems related to the surface area and volumes. And in further videos we are going to solve many problems based on the hollow cylinders, cones, spheres, cuboid. So be connected. Thank you.